Today we will solve the problem 4.37 of Griffith third edition Introduction to Quantum Mechanics. This problem consists of three parts. Part A is apply the S sub minus to the get vector 1 0 and confirm you get to square root of h cross 1 minus 1. Now this S minus is lowering operator. We are going to see what will happen if lowering operator act on get 1 0. So this is, let us consider the electron and proton as our example in the usual way. We can explain in the simple way using that method. So this S red color I have shown S1 S minus 1. This is the lowering operator for electron which I have shown in red color, and S minus 2 is lowering operator for proton which I have shown in green color. So now let S1 will act on this uh, spin up state of electron, and similarly S2 act on, first I have taken this pair, and let S1 act on this electron spin and S2 act on this proton spin. Then next pair you take S1 act on this electron spin and S2 act on this proton spin, which is in green color. Now we will see what will happen if S minus act on the spin up state. So the S minus matrix is, we know S minus matrix is H cross 0 0 1 0. It's a matrix form, and spin up state is 1 0. So column matrix. Now if you multiply this first row and this column, you will get 0. Second row and this column, you will get 1. So this is, of course, we have H cross. So this will be H cross, then spin down, spin flipped, that is up state to down state, because this is spin up, this is spin down. Then similarly, what happen when the lowering operator act on spin down, which is equal to S minus matrix is as usual H cross 0 0 1 0. If you multiply this first row and this column, you will get 0, and second row this column you will get 0. So this will be 0. When lowering operator act on spin down particle, it will be 0. You apply this here. So first one, what will happen? This red color, that is electron spin get flipped, it will come down with the value H cross. And what about this? This is already in spin down state. So spin down state, if lowering operator act on is, this will be 0. Next one is this also lowering, that is spin down state. When lowering operator act on spin down state, this will be 0. And what will happen? This lowering operator of proton act on the proton spin, then this upward spin will become downwards. So first one, H cross multiplied by this spin down, and already green is down, and second one, already red color is spin down, and when lowering operator act on spin up, it gives to H cross spin down, that is proton spin down. So if you add these two, you will get 2 H cross 1 over square root 2, then spin down down. So now you can cancel this 2 and the square root of 2, you will get square root of 2 H cross, and both are down, that is spin is minus 1. So this is equal to sorry, that the mth state is minus 1, down down. So this can be written as square root of 2 H cross 1 minus 1. You can use this formula S minus, when S minus act on get Sm, you will get this one. That is H cross square root of S into S plus 1 minus M into M minus 1 S M minus 1. Here in our case S is equal to 1, M equal to 0. So this will become 0. What about S1? 1 into 1. 1 into 1 plus 1, 2. 1 into 2 is equal to 2. So this will become square root of 2h cross. Here S is 1, M equal to 0. So already there is 0 minus 1 is minus 1. You got this. So we have proved that we are getting, when lowering operator act on 1 0, we are getting square root of 2 h cross 1 minus 1. Then we will move on to next. Next part B is apply S plus or minus to the vector state get vector 0 0 and confirm that you get 0. So now you will you take the rising operator S plus which act on 0 0. So as usual we have divided this into rising operator for proton and rising operator for rising operator for electron and rising operator for proton, and this for SMX 0 0 you get the linear combination of 1 over square root 2 spin up spin down minus spin down spin up. What will happen, you can see that when rising operator act on the spin up particle, then it will become S plus is equal to, you will get, this is S plus, that is H cross 0 1 0 0, and the spin up particle in the matrix form is 1 0 column matrix. So you multiply first row and this column 0, second row this column 0. So H cross this is 0 0 matrix. So naturally when rising operator act on spin up state, you will get 0. Similarly, what will happen when rising operator act on spin down particle, then this is S plus matrix as usual, and this is the spin down particle 0 1. Now what will happen if you multiply this? First row this column is 1, second row this column is 0. So H cross 1 0, 1 0 represents the spin up particle. So this will become H cross spin up particle. Now you apply it here. First you take this pair and let S1 that is electron rising operator act on this red color, it will be 0. When this act on the first pair, that is proton rising operator, this will go to up state. So spin up giving rise to the H cross. Of course you will get H cross. Then what about this? Sorry, I forgot to mention. Here you will get H cross spin up up, and minus. What will happen to if you use second pair? Then the first one it will go up. Second one green color, if you take it, it is already in up state. It will become 0. So up state will not you have to take upstate green color will become 0. Only the for red color this spin down of electron will go to spin up with multiplicative factor of H cross. So which will be H cross spin up minus H cross spin up will be 0. So we have proved it. Then what about this when lowering operator act on this? When lowering operator act on this, you will get that is when it lower, let us say it acts first on the first pair. So here this spin up will become spin down with multiplicative factor H cross. So when this act on green color, it will go to 0. So don't worry. Now you take the second pair. Second pair, if electron lowering operator act on this electron spin down already, so you will get 0. Only when this act on the spin up particle, you will get spin down with multiplicative factor H cross. So here H cross down down and H cross down down, which is equal to 0. Like here H cross up up and H cross up up will become 0. Then generally S plus or minus act on Sm, you will get this relation. That is S into S plus 1 H cross squared minus M into M plus or minus 1 H cross squared. Here S, M are 0. So naturally everything will be 0. So you will get net result as 0. Then we will move on to next session. We will move on to next session. Uh, Part C is so that get 1 1 and get 1 minus 0 are the eigenset of S squared with appropriate eigenvalue. So when S squared act on get 1 1, it is equivalent to the S squared operator can be written as S1 squared S2 squared plus 2S1 S2 because S1 S2 commute with each other. Then this 2x1 x2 can be expanded like this: Sx Sx Sy Sy and Sz Sz. Both act on spin up state. So all act on spin up state. So already we have seen when S1 squared act on spin up state, it will not change the state. You will get to spin up with the multiplicative factor 3 by 4 H cross squared. Same is the case with this one. Now we have to find this Sx, Sx, Sy, Sy, Sz, Sz. So first we will take Sx, Sx, spin up state. This Sx matrix is H cross squared, sorry, H cross over 2, 0, 1 and 1, 0. Then it will act on spin up state of electron. Then this is for proton. Sx, which act on this spin up state of proton. So this is H cross over 2, 0, 1, 1, 0. So now if you multiply this first row and this column, you will get 0. Second row, this column, you will get 1. Similarly here, first row, this column, you will get 0. Second row, this column, you will get 1. So this will become H cross by 2, this is spin down, this is also spin down. So this will become H cross squared over 4. Both will be spin down. So it will flip the state. That is very important. And then we will see for Sy and Sz. Now we will see what will happen if Sy act on the spin up state. Then this is the Sy matrix we have seen. That is H cross by 2, 0 minus I 0. And spin up state 1 0 for electron, this is 1 0. Similarly for proton, same Sy matrix multiplied by this spin up state. So you multiply first this, that is first row, this column, so which will be 0. And second row, this column is I, and that I am bringing here, this will become 1. So IH cross by 2, 0, 1. Same thing will happen to the proton also. I here H cross by 2, 0, 1. So both comes to spin down state. So initially it is spin up state, this is a spin down state. So you will get minus a h cross squared over 4 spin down because this I h cross into I h cross is equal to minus h cross squared. Similarly for SZ, so this is SZ matrix and this also SZ matrix which act on spin up state 1 0 and 1 0. Now you multiply this 1 0 that is first row and first this column is 1 0. Second row this column is 0. Similarly for this one. So this is h cross by 2 1 0 h cross by 2 1 0. That is same spin up state. So h cross squared over 4 spin up state. Now you can write this. What is s squared? Get 1 1 is equal to s1 squared. S1 squared spin up. This value is 3 by 4 h cross squared spin up. Here also 3 by 4 h cross squared spin up. Then the xy, it will change us the flip the state. Spin up become spin down. Similarly for y, you can see here itself minus h cross squared over 4 spin down. And for HZ matrix, this is SX matrix, SY matrix and SZ matrix is equal to plus h cross squared over 4 spin up. You can compare this first two term. Same state with the same multiplicative factor h cross squared over 4. So this will become 0. Then you can see this 2 will get cancelled with this 4 which will become 2. So remember that these three states are spin up. If you add first 2, you will get 3 by 2 h cross squared, both are spin up state. That is why we are able to add. Then here also h cross squared, both up state, which will become, if you add 2 h cross squared up state, so which is equal to 2 h cross get 1 1. So naturally this get 1 1 is eigenstate of operator S squared. Then we will move on further. Now we will see what will happen if S squared act on 1 minus 1. So S squared can be written as S1 squared, S2 squared plus 2S1, S2. And of course, as we have done earlier, you expand this like this. SX, SX, SY, SY, SZ, SZ. So what will happen when S1 squared act on this spin down, both are spin down, so it will not change the state vectors. So this will be simply 3 by 4 h cross squared spin down. Same thing is here as we have done earlier. So 3 by 4 h cross squared spin down. Here SX, we have seen this will flip the state. So this will give you the h cross squared over 4. Both will become spin up and spin up. What about SY? This is SX. SY, it will flip the state. That is spin down will become spin up. And you will get minus h cross squared over 4. And HZ will not change the state. So this will be h cross squared over 4 spin down and spin down. Now you can cancel this because spin state for both is up and multiplicative factor also common h cross squared over 4. So this will become 0. And you can cancel this 2 with this 4. You will get 2. So now you can see this is downwards, both downwards, here also downwards. So if you add these two, you will get 3 over 2 h cross squared, and spin down down, and this is h cross squared over 2 spin down down. So which is equal to, if you add both, you will get 2 h cross squared spin down down, which is equal to 2 h cross get 1 minus 1, because both are spin are downwards, so naturally this is minus 1. So 1 minus 1 also I can get up s squared. We have proved both. Thank you very much for watching my video and supporting me continuously. Thank you very much.